Hi, and welcome to this introductory series on the neuromuscular junction. This three-part video series will serve as a basic introduction to the neuromuscular junction, neuromuscular blocking agents, and reversal agents in relation to NMT monitoring. In part 1, we'll be focusing on the neuromuscular junction, and how an action potential generated by a motor neuron results in a muscle contraction. When considering a motor neuron, it consists of dendrites, an axon, and terminal end bulbs, and ultimately innervates the muscle fiber. The neuromuscular junction is the junction or space between the end bulb and the muscle. A neuron will generate an action potential which will then propagate along the axon to the end bulb. This causes a chemical reaction in the junction, leading to a muscle contraction. When taking a closer look into one of these end bulbs, we can see how a neuromuscular junction operates. A neuron generates an action potential which travels along the axon towards the end bulb. The action potential causes calcium channels to open, and calcium ions flow into the end bulb. The calcium ions now cause vesicles filled with a neurotransmitter called acetylcholine to release their contents through the end bulb into the neuromuscular junction. Once in the junction, the acetylcholine will now bind to the postsynaptic receptors along the muscle fiber. This will cause the sodium channels to open. The open channels will cause an influx of sodium ions into the muscle fiber. This will generate a muscle action potential, causing the muscle to contract. Once the contraction is complete, the acetylcholine will unbind from the postsynaptic receptors and move back into the neuromuscular junction. The acetylcholine now binds to a special enzyme, called acetylcholinesterase. Acetylcholinesterase will break down the acetylcholine into two molecules, choline and acetate. Choline can now be recycled back into the end bulb and combine with acetyl-CoA to make new acetylcholine, effectively replenishing the pool of acetylcholine available in the vesicles in the end bulb. This covers the primary function of the neuromuscular junction and how an action potential generated by a neuron results in a muscle contraction. Thank you for watching part 1 in our three-part introductory series on the neuromuscular junction. Please continue with the rest of this series to see how neuromuscular blocking agents and reversal agents operate in the neuromuscular junction.